Hello and welcome to your video on linear versus nonlinear equations. You know that the traditional slope-intercept form is y equals mx plus b. So y equals the slope times your x variable plus b, which is your slope-intercept. This is a linear equation. It's called a linear equation because when you figure it all out, you get a line. That's why it's called linear. There are lots of different types of graphs, though. So when we think about graphs, we can have linear lines like that, or like that, but we can also have goofy stuff. We can have this. That is a legit graph. We can have this. Another legitimate graph. We can even have that type of stuff, where that is one equation. Yeah, some of this stuff you're not going to get until probably calculus. But the point is that graphs can look all goofy like this. Well, in Algebra 1, we really only want to deal with linear equations for the most part. So I just want to point out how you can tell the difference between a linear and a nonlinear equation. Nonlinear equations have exponents, or they have square roots. So if you see an equation like this, that is a nonlinear equation. See how you have the squares here and you have the cube there? In a linear equation, you don't have any of that stuff. It's just a regular y and a regular x, and that's it. Well, as soon as you get any type of exponent, you're probably not dealing with the line. And when I say probably not, I'm going to say like 99.7% of the time you are not dealing with the line. Same is true if you have something like this. See how we're taking the square root of 5y there? Yeah, that is not going to be a normal line equation. So, when you are faced with an equation that looks like this, you need 2 points, right? 2 points to calculate a line. 2 points determine a line. If you have anything like this, you need lots of points. I would say, well, 3 for sure, but really more like 4 or 5 or maybe even 6, because you don't know enough about graphs yet to anticipate which ones are going to look like this and which ones are going to look like that. Oh, I didn't show you another popular one. Another popular one looks like this, like a U. Anyway, so you need lots of points. So there are a couple of times in your cities that Fred is going to say, what do you think this funky equation looks like? And you're going to have to calculate more than 2 points in order to see how that line is really moving across your graph.